Assalamu alaikum wa rahmatullahi wa barakatuh. Today, inshallah, it's me Sultan Sharibi, and today, inshallah, I'm going to talk about the first chapter on control system course. Right now, I'm taking this course with Dr. Fitriyan Imaduddin in Islamic University. This is our reference book for the course, which is the Control System Engineering, the 6th edition. Overview, inshallah, on this presentation I'm going to talk about introduction. I'm going to give an introduction about a control system. What do I mean by control system? Then we are inshallah talking about a history of control system, system configurations, analysis and design objective, the design process. What is the process that we should follow when we are designing a control system, computer-aided design, and a control system engineer. Starting firstly by what is the control system? When we hear a control system, we should actually divide the control system into two words. The first word is system, then the second word is control. So we'll start what is the system. As we can hear, let's just draw and assume this is a system. A system actually is a set of components or elements. Those elements are working together. Okay, so I have here what we call an input to the system. Well, this input will make the system work together to achieve a required thing, call it the output, or to achieve a purpose. Okay, so the system component or element, those elements working together, it's influenced by input and producing an output. Okay, so now what is the control? Control actually refers to the mechanism or the process that we use it. Okay, this is the system, input, output, the way of processing, managing, directing, and regulating the system. It is called the control. It's called the control. So, okay, usually or often this control process is unseen but present in many applications. Why we should use control to achieve stable in the system? We want to make the system stable, and we trying to maintain the performance of the system, trying to increase the performance and the efficiency of the system. So as we talk, we said that the system set of component or element influenced by input to achieving an output. The process or the way that we manage and control and regulate the system, it's called the control. From here we can say that control system is a system made up of devices of element that manage, command, direct and regulate the behavior of the other devices or system to achieve the desired result. So here is our control system. This system consisting of a lot of devices, a lot of elements. Those elements start to manage, to direct, to control the system to achieve the desired response. So, and one example of it like the thermostat. If I assume this is the room and the room has a thermostat, I set the temperature at 25, the thermostat will start to work and will give a signal to the controller to make the system start to behave in a way that this way will make sure that we are going to achieve the 25 temperature that we needed. What's the key component? We should focus on the loops the control loops, and we then in the next coming slide we are going to talk about the two types of the loops, the open loop and the closed loop, and the objectives that we want to make sure that the system will behave in the way that this way is going to meet the cause that I wanted. Like in the thermostat case, I want 25. The system start to behave in a way that's going to make sure that we are achieving the 25 Celsius that we wanted. Like now we're talking about some example and application of the control system, like in the elevator, as we say the thermostat, and in the manufacturing we use a lot of controlling system like the robotic and the machines that on the manufacturing field. So what is the role of the control system on the elevator? On the elevator, actually, the control system is going to give us an ability to feel smooth moving. We are going to stop on the right floor, on the correct floor, and from the control system, the elevator can understand the input from the person that's sitting, if the person is sitting on the second or the first or the third floor. The thermostat actually, as we said, if we set the temperature at 25, thermostat is starting to turning on or turning off the heating and the cooling devices or system. On the manufacturing, like robotic and machines operate under precise control to ensure efficiency, accuracy, and safety. So here, as we say, the control system set of components that working together to achieve the desired want that I wanted. Like in the thermostat, I want 25. The control system is trying to achieve it and trying to behave in a way that we can achieve this desired input. What are the advantages of the control system? The first advantage is the power amplification. The second one is the remote control. That we start to make it automatic control system. Convenience of input form, that the control system can understand the different form of the input, and compensations for disturbance. Historical development, we should know that the control way or the control process, it's not a new process. Actually, it's an old process, and a lot of scientists, starting by the ancient Greek feedback system. The ancient Greek feedback system. The ancient Greek used an early feedback system like the water clocks. Then the control system started to develop. We reached to the 17th century, and in the 17th century we used the control system steam pressure control and temperature regulation. And in the 19th century, like this James Watt produced a mechanical device used in steam engine to regulate speed by controlling steam supply. Also, like the Clerk-Maxwell, laying the groundwork for modern control theory. Types now of control system. When we are talking about control system, we can define the control system based on two categories. The first category, when we talk about the one that control the system, even if it's a human controlled system or automatic controlled system. Okay, so if it's a human control system, that means that it's operating manually by a human. If it's automatic, so it's a regulated system using feedback loops. There's some devices that will do the automatic controlling system. The second category that we can define the control system or talking about the type of the control system is based on as I said, on the loop. So on the loop we have when we are talking about the loop, then we are talking about the automatic control system. We are not talking about a human, we are talking about an automatic control system. So type of the loop, we have the open loop and we have a closed loop. The coming next slide, I'm going to show the difference between the open loop and the closed loop. But now, for now, open loop means that there is no feedback, like toaster. Closed loop means that there is a feedback, like thermostat. Let's start to know what do we mean by feedback and no feedback. In our example, as we said in the open loop, we talk about toaster. So what do we mean when we talk about toaster? Let's start to make it. Open loop means that the output will not affect the input. Okay, what do we mean? Let's assume this is the toaster, and this is the switch of the toaster. We put a bread inside the toaster, and I set a switch for 5 minutes. On the toaster, since the toaster is an open loop system, that means that the toaster will work for the whole 5 minutes, even if the bread is been burned or it's been burned. Okay, so the output will not affect the input. So the output will not give a feedback for the input. Okay, so in the case of the toaster, I use toaster for making the bread like in the gold shape. But even if the bread has been black, has been burned, the toaster will not stop till it complete the whole 5 minutes. Okay, let's read here. So open loop system. Disturbance, it's mentioned here, disturbance cannot be corrected for by an open loop system. The ultimate temperature in our toaster would be different from the given temperature. Okay, so the input in this case of the open loop will going to be different than the output on the open loop system. So in case of the toaster, it's unable to adjust it for bread thickness or whether it's made of white or whole wheat. In this, okay, so in the open loop system, the output is going to be different than the input, and there is no feedback will be given. The output will not affect the input. Okay, the output will not affect the desired wanted. On the closed loop system, actually, what we call it the feedback system, an example for it is the thermostat, and as I said, the output in this case will affect the desired wanted. Like in case of the thermostat, like assume this is the temperature and there is a thermostat inside it, and I set the temperature as 15, so the cooling unit will start to work till it reaches this temperature. What is the thermostat will do in this case? Assume we reach a temperature of 16. Then the thermostat will give a signal to what the unit or the device, which is called the controller, that I reached 16. So what should I do? Then the controller will understand that this is above what I wanted, so we'll give an order to the actuator. The actuator will start to make and to start to work for the planet to make it 15. Then is going to be what we call it the feedback unit or a sensor unit, and this sensor will measure the temperature and every short period of time, and will give also a signal to the controller again and again till we reach to the desired wanted. Okay, now we are going to see the block diagram of the input system, the open loop system and the closed loop system. So this is for the open loop system. Here, let's go through it quickly. Here we have input or reference. Input or reference is the desired value that we wanted. We have here the transducer. This transducer will transfer the input in form that the controller can understand it. The controller will determine the action that we should use it based on the input given. Okay, so on our case, like the toaster, I put it in 5 minutes. The controller will give an action to make the machine working for 5 minutes. The process or the plant is the part that we are executing the action on it or the task on it. Then we have here the output or the giving or the last our result, the last value. But in this case, on the open loop, since there is the disturbance and there is an error and there is no feedback, so the output on this case is not going to match the input, okay, because due to the disturbance or the error. On the second type, which was the closed loop, the same. Here we have the input or the giving information or the desired what we wanted. The transducer will transform or convert the input into form that the controller can understand it. Here we have a very important device, which is the summing junction. What's the summing junction? The summing junction will compare between the input and the output to calculate the error. And based on this error and based on the input, the controller will work based on the given data. Okay. Then the planet is the processor executing the task on it, and in this case, the output will match the input. So why the output in this case is going to match the input? Because of the output transducer or the sensor, because the sensor or transducer output will going to measure the output. Okay, we're going to measure the output and give a feedback to the controller that the output is matching the input or not. Okay, so this is the main difference between the closed loop and open loop system. Okay, this is the main difference between the closed loop and open loop. And the output transducer or sensor will usually measure the output if the output matching or not the input. Okay. Then analysis and designing objective. Why should we analyze the objective? We should analyze to maintaining system stability and lowering the steady state error. We are looking here for stability. It's one of the important word ever. It's stability. How to achieve stability? By reducing making the natural reaction decaying to zero in mind. Okay, we want to reach to a zero decaying. Okay, and we have here what you call it, that the sum of the total response is the total response is the sum of the natural and forced response. Okay, then here is the process that we should follow when we are looking for designing controlling system. Firstly, we should choose a physical system. Then we should create a functional block diagram. We should create a mathematical model. Then we start to reduce or make the block diagram smaller, and we should conduct a system analysis and design. Then some of the applications that we may use and help us, like the MATLAB and the Simulink. By using this MATLAB or Simulink, we are going to improve the accuracy and efficiency. Then the control system engineer. Here we are mentioning that actually this work or this control work is not done. It can't be done by a specific one engineer, like the mechanical or civil or electrical. No, it is work with experts from different fields like biology, mechanical, electrical, all and computer. All of those should work together in case they to achieve the control system, because we should because actually there are many components like the sensors, motors, and different circuits. All the all engineers from other fields should work together to achieve the wanted. Thank you so much. I hope I explained it in a good way. Thank you so much, Dr. Fitrian. Assalamu alaikum.